would like to share some sample that created soft mask by procedural way in material. So everything actually is coming from UV, from U and V to make a soft mask. So let's check the first case. We're doing this to calculate a curve value. We can make the two sides gradient mask. If we're using a linear value, so the way is to using R channel, the VU, and subtract 0.5 and the scale multiply 2. Get the absolute value, we can get the linear value to doing the two-side gradient. So you can check these two results is kinds of different. For the curve value, it will be more softer. So we can check in the preview note. Yes. Yeah, you can see it's much softer in two-side gradient. And the linear value, we will get the sharpen more two-side gradient. And for the next, it's a very general case. We need a spot or circle mask. So we are used to using distance node. So for the first step, we have to multiply the tiling, the U and V to be 2, and get a distance to 1. So we can get this gradient look. So doing the 1 minus and get saturated, because after the distance, the maximum value in this square is not 1. It's will over to 1. Actually, in the top right corner, in each corner, the value is square root of 2. So you can have a quick check by fractal value node. You can see it's over 1. So when we're doing a 1 minus node, we will get negative value in those corner. So when you see the preview node, it looks like black, but it's not exactly 0. It is negative value. So it will causing some issue when you're doing some multiply work with other result. So ideally, we should do in a clump. So here I using saturate to clump the value between 0 and 1. So suppose you want to make it full value return to 1, you can do in this, because I mentioned the maximum value in the corner is square root of 2. So we can do in the divide. So you can see it will return to the 0 to 1 at the corner, but it will not the perfect circle what we're looking for in the case here. But in case you need something like this, you can do in this way to return your value to 0 at the corner is 0, to the center is 1. Okay. And for the next, by using distance node, we also can create something interesting look if we change the tiling and the distance to 1. So in this case, I just multiply the 2 to U tiling, and the keep V tiling is 1, and the distance to 1. So we keep the center on the bottom and get these kinds of heel look. And another case, we also change the value between in the UV and get the distance based on the center position changing. So we got this kinds of shape. And in this case, it's also kinds of two-side gradient, but it can be modified dynamically, because when we changing the value here, you can see the middle will be changing if even I tap 1, it's got a fully one side gradient invert in the center. And it's quite inconvenient when you're doing something need to be changing the gradient dynamically. Okay, and the next case is the sloping gradient. So it's start from UV, break, and add the U and B together, subtract 1. So in this node, we got a value from negative 1 to 1. So we need to use absolute node to return the value, become the mirror from 1 to 0 to 1, and then get a 1 minus, do some powers work to make a good looking gradient what we're looking for. And the next is using a very general way to doing a mirror value. So here I multiply U and B with the 1 minus value and multiply 6, and then ensure the value just between 0 to 1. So I use in the saturate and break 2 node. So if we multiply U and B, we will get this kinds of raw square mask. Using minimum value, we will get this kinds of square. It's a sharpened edge. And add together and return, subtract 1 for return the value to 0 to 1, and also do this subtract to saturate, to get this result. Ensure the value just between 0 to 1. So if I change the value here, you can see the difference. The result got been changing and get different look what we want. So you can thinking about what do you looking for, and this is actually this way as we mentioned previously. In here, doing this way, multiply with the negative value to himself, we will get a curve value. So if we do by linear value, it will be different result. So you can see the results was been changing. It's different when you using the curve value and the linear value. So in the next sample is kinds of capsule look. It's also doing the trick between the linear value. This is this one is using curve value and multiply. A value make it stronger, which means we're pushing the center to get a more round shape. So you can try to the different value to get what you're looking for. It's also the same idea because we multiply the 8, the value will totally go to 0 to 8. We're too big. We have to ensure the mask value is between 0 to 1 to avoid causing any value issue. Okay, so and the next is also another kinds of capsule look, I guess. Yeah, so here is using the linear value and do some power work to get these kinds of round shape what we're looking for. And yes, and the next is a triangle. It's a trick. You have to use in the V direction, become the mirror gradient, two-side gradient, and add to the R channel. Yeah, of course, if we change the here is for change your direction. You also can invert the RNG to get the vertical direction triangle. You also have to do the subtract because saturate, because we do the subtract previously. So which means in the black area, what we look here is will actually get some negative value. We don't prefer to get any negative value for opacity output. Yeah, this one is diamond soft mask. Doing the two-side gradient and add together, do the subtract, also do the saturate, clamp the value between 0 to 1. And this one is using the sine to get the sine wave soft mask. And the last one, if we need some organic or randomly soft edge mask, this is a good way to using a sample texture. So here I get a sample texture and add with the two-side gradient. Multiply 2 is another way to make the one direction soft edge. Yep. And this is two-side gradient. Also here doing a subtract, we need to ensure value to 0 to 1 to do so by using saturate node. So that's all for this video. Here totally have 16 soft edge masks you can reference for your material work. And doing a procedural way is also a good solution instead of using the texture, because texture have a map issue, so also have a resolution concern. So doing those kinds of simple masks, we prefer to using this loss procedural way in quick and to get the good visual result, I mean the resolution on the screen. And yeah, for sure, for those very customized soft mask, we should create a sample texture instead of doing a very complicated calculation like a kinds of Photoshop work in material. I think it's not a smart way to doing that kinds of work, because it will take in too much performance and instruction in material to causing some technical or performance concerns in your project. So it's quite dependent on what kinds of case or project technical concern to choose a suitable way to make this. But here is a most very basic soft mask we can do in quick in material solution. And the most important thing, what I mentioned multi-time previously, we have to ensure your value just being clumped between 0 to 1. This will be good for your value handling in your material. Don't losing too far, especially go into negative. It will ruin your visual. Yeah, I think that's all. Here is 16 most very general common soft mask in material. Wish you like it, and let's keep exploring more by self, and see you in next video.